Hello and welcome to Earth911's Sustainability in Your Ear, the podcast conversation about accelerating the transition to a sustainable carbon neutral society. I'm your host, Mitch Ratcliffe. Thanks for joining the conversation today. Silicon-based solar panels have made tremendous progress since they came to the public attention for the first time when the Carter administration installed them on the roof of the White House in the 1970s. The cost of electricity that they generate has fallen by 99% since then, as silicon panels have achieved 20% efficiency in converting the sun's energy into electricity. But there are other materials that could deliver even more energy at a lower cost. Perovskite, a calcium titanium oxide-based nanomaterial, can turn more than 25% of the sun's light into electricity, and a recent Nature Photonics report suggests that it could become 2.5 times more efficient in the next few years. Our guest today is Scott Graybeal. He is CEO of Caelux, which has developed a perovskites-based nanotechnology that can improve the performance of silicon solar panels. It claims that it can produce 30% more power from the sun at a 10% lower cost than traditional silicon-only solar panels. Scott brings a long resume to Caelux, including time as a nuclear submarine officer and leader of Energy Solutions, a division of Flex Limited, a publicly traded solar generation, electricity storage, and LED lighting innovator. Caelux recently closed an additional $12 million in funding to build a manufacturing facility that will produce up to 100 megawatts of capacity annually. And you can learn more about Caelux at caelux.com. Caelux is spelled C-A-E-L-U-X, caelux.com. Let's get into the conversation. Welcome to the show, Scott. How are you doing today?
I'm doing great, Mitch. Thank you for having me.
Welcome to the show. It's great to connect with somebody who was served in the Pacific Northwest. You were on a nuclear submarine. What was that like to be a naval officer on a nuclear submarine?
Well, it was a very challenging experience. And, you get out of nuclear power school and submarine school and you think you know everything. You're 23 years old, and you show up to this ship and you learn very quickly that you don't know as much as you think you do. And it's a humbling experience for sure.
I think that's actually where we are with the entire sustainability transition, is that we are just beginning to understand the complexity of the system that we've messed up so dramatically. But what are the key lessons you've learned along the way?
Well, I would say most importantly was how to really deal with pressure in situations where it truly is life and death type of a scenario. Mm-hmm. And I think that was the experience that I definitely picked up from that experience. And also just to really understand that, nobody's as smart as all of us. And I think that the nuclear Navy's done a great job in terms of driving in situ collaboration in the heat of the moment so that the best ideas surface to the top and are acted upon no matter where they come from in the organization. And I think that's been a lesson that I've carried forward in my civilian career over the last 25 years. But along the way, when I left the Navy, I worked for General Electric for a bit and then got into the semiconductor industry, where you really get to meet some of the brightest minds on the planet. And learning how to work with people of that caliber and harness their talent and their skills to go in a particular direction, was a key lesson for me in my formative years as becoming an executive. And one of the things that I gained a great appreciation for when I led the energy business at Flextronics was, what's it take to really scale? Mm-hmm. Kinds of systems and processes do you need to have in place to take a small business to become into a phase where it can become a large business? And those are the same kinds of principles that we're applying here at Caelux today. When I joined 3 years ago, it was a 8-person startup, and now we've got 50 people, and we have a factory that we're ramping at the moment, and we're going to be taking this global at some point around 2025.
Well, we have a very well-established silicon-based solar panel industry. Perovskites really have a lot of potential to improve the performance of solar panels. How does it do that? Can you just briefly explain how the addition of a perovskite to a solar panel changes its performance?
Yeah, absolutely. So the difference between silicon and perovskites are that silicon tends to absorb light, that infrared range. It's the best at that, where perovskites absorb light is more in the higher energy spectrum, so from red and beyond. And so now you're able to combine these two technologies so that you can absorb more of the sun's available spectrum.
A little like a radio tuner in a sense.
Yeah, I guess you could say that. Yeah. And I think in our particular case, the approach that we have taken, our proprietary approach, is to go and take glass and coat it with a 1 micron thick layer of this perovskite material stack, and then connect these electrically in parallel so that the two materials can really run independently of one another, but passively is connected, such that you just add the currents at the end, you match the voltage between the two, and you add the current, so you get a higher power device at the end of the day.
Now, the fact that you can add a coating, does that suggest this could be applied to an existing panel, or is this something that needs to be integrated during the manufacturing process?
That is probably the most common question I get, and I get it for good reason, because a lot of folks look at their solar arrays and think, wow, I really want to repower. What can I do to boost the efficiency? But the way that our technology works, it has to be coated on the underside of the glass and integrated during manufacturing.
Okay.
So our model is that we work with module manufacturers and improve the performance of their technology. We'd love to have something that we could just say, hey, let's roll this film out. But the issue you run into is, how do you connect it now electrically? Do you go into the junction box in the back of the module? That could be really problematic. Or to use current transformers and clip little CTs onto the wires to boost the performance. And there's a lot of losses associated with that technology. And so one thing you have to be mindful of is that, okay, how are you impinging potentially the insurability of a project? And so that's a much steeper hill to climb. But the reason why we're focused more on new modules is that market is between 4 and 4.5 times larger than what the, let's say, repower market would be.
Since it can be applied as a thin film, is there a potential to develop a form of the technology that can be overlaid on windows, for instance, and begin to harvest energy from the sides of buildings?
Yes, absolutely. In fact, there are a number of companies that are going down that path. That's typically what we call like a building applied photovoltaic or a building integrated photovoltaic. There is that approach that is available. It's not something we're choosing to do in the near term. We look at the largest market opportunity is really terrestrial PV, and terrestrial PV that complements silicon at this phase. So we think that's probably the best market for us to go after. Even outside of China, we really look at our key markets as outside China.
Now, you are building a manufacturing facility, but that'll be a manufacturing facility for the material that your customers will apply to their panels, if I understand correctly. In other words, you won't go buy a Caelux panel. You will buy a Caelux-enabled panel?
Yeah, I call it a Caelux enhanced module. Yeah. Really is what you'll end up buying. And so our business model is to consign glass from module manufacturers. So we don't want to get in the middle of that glass supply chain. Oftentimes, these manufacturers have a couple of decades long relationship with their glass suppliers. And so what our intent is to consign glass from them, them being our customer, coat the glass, and then send the glass on its way. So ideally, we want to be somewhere along that logistics chain such that we don't add additional time necessarily, other than just what it takes for us to go and deposit our material system onto the glass. But that's really the approach that we have taken with this. And so the concept of consigning materials to another manufacturer is tried and true in the solar industry. I used to run about 2 gigawatts of PV module assembly, and many of my customers had us just consign materials from them, and we just did transformation. So very much the same approach.
Now, you have a product called Caelux One, and is this something that a solar shopper, whether they're a business or a consumer, should be asking about when they purchase a panel?
Yeah, absolutely. It's not available yet. So our launch date is Q4 of 24. Mm-hmm. So that's when the product will be completed, and it'll probably hit the market in Q1 of 25 from our module partners. And so the intent is that, yeah, we would love it if every project developer in the world would look at a project that they're working on and say, let's Caelux this project to boost our returns. Because we feel that we deliver a pretty significant advantage. And if you're a developer of a project, the way you can think about it is you're going to have about 11% lower costs, and you get 20% more kilowatt hours over a 25-year lifetime of the project. But from a fiscal standpoint, you're going to boost your returns by about 36%. And that's what we call a levered IRR return. So there's a significant advantage for developers. For homeowners, it means fewer modules on your roof, or you could put just as many modules on and get more power out. So there's significant advantages for the entire spectrum of downstream users.
Now, your current lift in terms of energy generation, you're making a jump from 25%, or well, actually around 22% on average for solar panels, silicon solar panels, to about 30%. What does that represent in terms of an overall lifetime increase in generation to what you were just speaking about? Are you able to quantify that in a way that the average listener can understand?
Well, I just want to correct one thing. And so we really talked today about Caelux One about improving about 6% absolute. So I'd love to say 30 right now, but we'll get there.
I meant that the total generation capacity.
That's right. You are correct. Yeah. So it's about on a relative basis, about 30%. And your question again was more about the life.
You were saying you could buy fewer panels and get the same power, but let's say I just make the same purchase today over the course of a lifetime. Are we talking about a 30% overall increase? Again, I'm picking.
No, that's a really good point. And so because there is a difference in degradation between perovskites and crystalline silicon, both material systems do degrade. Today, perovskites do degrade at a faster rate. So even in consideration of that faster rate, perovskites can still support a 25-year module warranty in this 4-terminal configuration. And the important factor, though, is at the end of life, the module will still produce more power with the perovskite material system integrated into that stack than it would without. So you still will have a more powerful module at end of life.
So you're getting a lift at every stage in the life cycle.
That's correct.
Now today, a kilowatt hour of solar generated power is about 33 cents.
Right.
And where do you expect that to be in 2030 if perovskites are integrated into panels?
That's an excellent question, and it's a difficult question, but I'll just kind of give you the highlights.
Sure.
Look at it in 2 phases here. So we expect that Caelux One, when we launch that product, that will be on the market in 25 through our customers. We expect to see about, let's say, a 20% improvement in that cost basis. Let's just assume that you had a 3.3 cent kilowatt hour per kilowatt hour project. You could probably knock off at least 20% off of that. So you get down to maybe about 2.5 to 2.7 cents a kilowatt hour. Over time, though, as perovskites begin to really proliferate, what we'll see is module costs will dramatically drop. At some point in the future, we do see that perovskites do eclipse silicon. And there's a lot of good reasons why that should happen. But if that indeed does happen, then the cost of modules themselves drop dramatically. You're looking at a 50% savings just in the cost of a module alone, if not more. And that's because of the cost differential between silicon and perovskites.
Now, your first facility, the manufacturing site that you're building right now, will have about 100 megawatt per year capacity of production, as I understand it. How fast can you grow? How many more facilities do you need to build in order to really ramp up the availability of perovskite?
Well, it's amazing to see how much this industry has grown. I've been in the industry for about 15 years, and I remember starting and thinking that a 60 megawatt factory was a big factory. And today it's not, it's like a lab line. Even our 100 megawatt line that we call this our development line. It's really a pilot line at 100 megawatts. So we view that in 25, we're looking at some substantial scaling, multi-gigawatt scaling. And we have a ways to go in order to catch up to that level of capacity that's coming online for crystalline silicon. Today, there's about 300, 400 gigawatts of crystalline silicon manufacturing capacity. China alone has announced 1.2 terawatts of PV module production capacity. In the US, there's roughly 40 gigawatts of announced capacity coming in, and that's across the spectrum of cadmium telluride and silicon. So our perspective is that we're going to multi-gigawatt scale fairly quickly. The intent of this line is to really develop that basket of lessons learned, qualify new equipment, and to have a model that is really a hub and spoke, where we have a copy exact discipline from what we learn here in this site, the qualification of the equipment, the processes, everything that we need. So we don't have to have technology risk when we ramp another location. There should be a copy exact perspective from an equipment standpoint, from a process standpoint, et cetera. And so that's really what the purpose of this would be. We're looking at expansions in the United States as well as in India and Southeast Asia starting in 25.
What does a facility like this create in terms of the number of jobs, and what are the jobs that people need to be trained for in order for you to scale to 2 gigawatts, for instance?
Well, workforce development is one of our key initiatives as a company. So we really engage closely with government at all levels in order to support the kind of workforce that we feel we need. In fact, we participated in a session with White House staff a couple of weeks back talking about this topic exactly, because we see that there's gaps in the workforce today. We need to have everybody from the PhD level physicists and chemists all the way down through people that are very comfortable working in a factory environment. And so, for example, the bulk of our jobs here at this site are what we would call operations jobs. And that means everybody from logistics, equipment operators, equipment maintenance engineers, and technicians. And so at a minimum, we need to see people with more what we would call mechatronic training, so mechanical and electronics training, so that when they encounter a problem, they're just not going through the owner's manual, if you will, but they can actually bring critical thinking to problem solving. They don't need to be college graduates. In fact, I would prefer that we get people out of top tier trade schools and coming out of this type of an environment, because that's what we need desperately.
So how many jobs does do you expect one of your facilities to create?
So a 500 megawatt facility would create probably for us about 100 jobs. And if we kind of think about it in that sort of an increment.
And you're talking to the White House. They must be asking you, how many plants do you expect to build over the next decade or so?
Yeah.
What are we talking about in the United States in particular?
So we envision within the next decade, probably about 20 gigawatts of production capacity.
Okay. Let's take a quick commercial break, because this is a really interesting and important conversation. We'll be right back. Let's return to the conversation about perovskite-based solar panels with Scott Graybeal. He's the CEO of Caelux. So, Scott, perovskites are incredibly common in nature. They're the most abundant type of mineral, in fact. How are they extracted and refined? And what are the environmental impacts associated with producing them?
Well, that's a great question, Mitch. And I think that you would typically think that this is something that is mined because of this, as you said, they're so common. The reality is they're synthesized. And so they're synthesized in the lab, they're synthesized in production. And so
synthesized from what?
Well, from really basic materials. And so what we use is called a metal halide perovskite system. And really it's common, readily available precursors that are combined in a certain way and processed in a certain way to create this perovskite crystal structure. And that's why they have the name that they do. We call it ABX3, and it is a calcium titanate material that's found in nature. And that's where we first discovered this crystal structure. And so we basically copy that crystal structure. And it turns out if you use the right elements and the right materials and you process them in the right way, they make very low cost yet powerful solar cells. And the challenge that the industry has had is how do we increase durability? And we're very much on the cutting edge of that. We frequently benchmark others in terms of durability, and we feel that we're at the front of the pack when it comes to this durability work today. And so we feel quite confident about bringing products to market in a relatively short time horizon because of our work there. But that's the little bit of a misunderstanding about perovskites. They are not mined. They are materials that we actually synthesize in the lab. It's the best of organometallic chemistry for our organic chemists out there. So it's something they can wrap their heads around pretty readily. But it's really that we're fabricating them in situ.
And are there byproducts of the refinement process that we should be aware of? Is anything left over or extruded into nature that we need to clean up?
No, we're very mindful of that. And we're operating in California. We have the strictest EPA standards in the country. Cal EPA has very, very strict standards. And so we monitor all of our effluent. We have a tremendous amount of recycling in our process today. And we work with tier 1 waste disposal people when we do have hazardous materials we need to process off site. And so, there's very little that we really have to be concerned about from that standpoint, but we take it very, very seriously, because there are obviously in any of these endeavors, in any manufacturing of energy assets, there are hazardous materials, but you need to have people that are trained and qualified to manage those and follow the strict guidelines that are out there. And so our belief is that if we can produce in California effectively, we can scale this anywhere in the United States.
Is the process water intensive?
It is not. In fact, they do not like water. Yes, perovskites, that is probably the The primary degradation mechanism for perovskites, that people talk about perovskite degradation, we don't like water. We monitor it quite closely in terms of humidity and temperature and so forth. The water that we do use, though, is for cooling water for our systems, and that's really it.
Now, I read a 2020 report in Nature, and other researchers as well have raised this concern. The lead is used in the absorber layer of a lot of perovskite panels, and they have suggested that tin would be a better option. What's your approach to preventing lead contamination from the panels that you make or that you contribute to?
We have to probably put that in context. And I think it's important whenever we hear about using materials like lead, and we do use lead, we use a lead halide perovskite. Okay. Tin, unfortunately, is not as good as lead halides. There's a lot of work still left to be done with tin halide perovskites. They don't perform as well. They degrade faster. Their efficiencies are quite poor at this point in time, especially when you're looking at large devices. And by the way, we've scaled up to 1x2 meters. And so I just posted on LinkedIn last week was a picture from our line here, and it's probably the first 1x2 meter in the Western world, and it might be as large as what we've seen anything coming out of China. So it could be even larger than what they've done. So we've been able to scale this up to a size and a form factor that really is commercially viable, and that you can't get there yet with tin. But with all that said, I think the context we need to understand is let's compare this to the automotive industry. There's roughly 70 million cars are shipped every year, and every one of those cars, including your lithium-ion battery-powered EV, has a lead acid battery in it because your instrumentation is 12 volts. Mm-hmm. It's not, the bus voltage for the drivetrain, it's your instrumentation. So everybody's got lead acid batteries. So let's just assume that all of 70 million of those vehicles have a lead acid battery, 1 year's production. That 1 year's production is equivalent to about 2.5 terawatts of 4-terminal perovskite modules. To put that in probably a different way to think about it, if you stacked all those modules end to end, it would go back and forth to the moon about 11.5 times.
So relatively speaking, we get a lot more out of this lead than the lead that we are concerned about with regard to batteries, for instance.
Exactly right. And by the way, that calculation is corrected for solubility, because that's also the remark that you'll hear too, is like, oh, the solubility of this compared to that. But if you correct for solubility, that math holds.
Is there end-of-life remediation issues that we need to be aware of in terms of dealing with the lead?
Well, keep in mind that every solar module today, on average, has about 14 grams of lead in it already. Mm-hmm. There are some companies that have gone to great pains to remove lead from their modules, but they will tell you that it's been a kind of probably not an effort the market has necessarily recognized. And so to this day, you still see about 14 grams in lead in every PV module. We contribute less than 2 to that stack.
So really, it's a matter of we just need to plan to recycle these responsibly, and we're not going to end up with a lot of stuff, lead in nature.
Exactly right. Exactly right.
Well, let's hope we go there. Now, how do perovskite panels compare to silicon-only panels in terms of the carbon emissions over their entire lifetime? Do you have a sense of that, and have you been able to confirm any research that suggests that there is an advantage?
Yeah, absolutely. We've done our own calculations and we've compared it to what's benchmark studies. And generally, you see this expressed in terms of like energy payback time. And keep in mind the complexity of a silicon module supply chain, where in most cases, you're extracting coal to heat the furnaces to create ultra pure silicon that's then manufactured and then shipped to another location, yet shipped again to another location. So that's a pretty extensive carbon footprint. For perovskites, we don't experience that same thing because we have a low temperature process. In fact, we have to keep things at a relatively low temperature during the processing of these materials, at least the approach that we have taken. And so because of this low temperature processing, very short supply chain, which can become even shorter over time, thanks to things like IRA, we see that the energy payback for us is probably 1/10 of what we would see with a silicon module.
The IRA really did change the environment, the investment environment, but it's also under threat right now. There's a lot of talk about repealing it if certain parties win the election next year. What would that cost the United States in terms of its solar competitiveness if we were to pull back on the IRA?
It would be absolutely devastating. I mean, that there is no other way to put it. It would be absolutely devastating. I think this is the first time we've seen a coherent industrial policy from the United States that wasn't tied to, let's say, a military industrial complex of some sort, or highway infrastructure from the 1950s. You could say that's probably the last time we had this civilian industrial policy. And it would be devastating because everybody loves to point at China and say, gee, they're cheating. Look what happened. They've got all this PV module capacity. And this is the first time the United States that says, look, let's go reclaim leadership in a technology that we helped to develop and promote. It would be a tragedy. And I think that when people ask me, what are the things that I should do to, reduce my carbon footprint or to make myself a better citizen when it comes to climate change, you can make all the little micro changes you want. You can compost, you can get an EV, you can do the things that make you feel good. At the end of the day, the most important thing you can do is vote.
That's a great point. Now, in terms of the U.S. being dependent on other countries for solar capacity, we're stuck with a lot of Chinese resources right now. Do perovskites represent an opportunity, because they can be synthesized here, to be the world leader in terms of solar generation capacity, say a decade from now? Is this one of the bases of our renewed competitiveness?
It absolutely is. And I don't say that just from the standpoint of being a CEO of one of the leading perovskite companies. But if I was on the outside looking in, I would say this is a strategic inflection point in the industry where we could really transform the supply chains associated with PV and create something domestically, leveraging US-based materials, US-based labor and technology to really reinsert ourselves back into this ecosystem. This is an opportunity for energy independence in a different dimension now, saying, look, it's not just energy independence from the Middle East and fossil fuels. This is energy independence in terms of what we can do here domestically, create good jobs, create the energy that we need, and have this complementary facet of solar as part of our overall energy mix. This is our opportunity, and we have to jump at it.
Now, you mentioned earlier that perovskites could ultimately replace silicon by 100% of the silicon in a panel. Does that mean that we could have a completely domestic supply chain for solar?
We absolutely could. We absolutely could. And just to keep in mind, there are precursors that we would have to start manufacturing here in the United States. We're still forced to go overseas to find some of the raw materials, not because they're rare, not because of they're mined somewhere else, is that we have lost the capacity, whether it be will, intellectual, capital-wise, whatever, to manufacture those things here in the United States. We're on the forefront, though, of driving this change. We're working with our representatives in Congress. We're working with government officials about what's it take to go and build out a domestic, 100% domestic supply chain for this perovskite technology. And these are not materials that are difficult to fabricate. Where we do have an option to choose a domestic supplier, we absolutely choose it, so long as it's cost competitive, and we do educate our suppliers around what their competition is selling for, so they have an impetus to invest. And we work with them in terms of volume forecasts. And the concept is simple, like, look, I will buy from you at this price point, and this is what my volume target is, but I need you to work with me today while I'm still a little bit smaller. But then, once we scale, you're going to be our partner going forward. And one of the things that's interesting to note, it's difficult to find low iron glass. And this is more dealing with the 4-terminal conversation, because silicon cells typically need low iron glass. Most manufacturers of glass today will tell you that if I make low iron glass, that impinges on the lifetime of my furnace, my float line. And so and there's some physical reasons why that's the case, but there is an impact. But most low iron glass today is coming from overseas. In a couple of cases, there are going to be low iron plants in the United States, but not nearly the capacity that we need. And so
besides the low iron glass, are there specific critical minerals that we should really be looking at improving our ability to create here in the States?
I would say no, especially when you look at the integrated relationship between Canada, the US, and Mexico. I think that we have everything that we need. For sure, we have everything we need. There is nothing there that is really going to be problematic. And, if we really look at this as being a USMCA opportunity for all three countries, as it should be viewed, I think we're in great shape overall, and we would love to see perovskite manufacturing locations throughout North America, in a sense where why not produce these materials close to implementation, close to where customers are going to be, reduce supply chains. These are very cost-effective factories to ramp. The payback period for us is less than a year for a perovskite factory.
That suggests you should be building factories as fast as possible. How many do you plan to build in the next half decade?
Well, by 28, our current plan is to have about 30 gigawatts.
Okay. Just to break that down, how many facilities does that represent?
Well, the way I would think about it is what countries does it represent? and for us, a line, a minimum size line, and we call it more lines versus factories. So a line is about 500 megawatts. We would look at building out 500 megawatt blocks, and it could be a very large campus. It could be,
Okay.
Yeah, it could be depending upon where we are.
It's more of a modular approach to manufacturing expansion rather than we go build another location.
That's exactly right. That's exactly right. And the kinds of things that we look for, obviously, are going to be relationship with the local community, relationship with the state. If it's another country, the relationship at their equivalent of the federal level, in order to really say, look, we have an opportunity for job creation and growth and cutting edge technology. How can we partner to really make this happen? And so that's kind of the foundation. And from there, we really look at basic requirements, electricity infrastructure, things of that nature, right? And so and availability of skilled workers. And that's really an important consideration. So we view this as being a global technology as well. I mean, yes, there's massive benefits to the United States. I am an American, and, we clearly are going to be doing a lot here to help the US, but this is something we're going to be scaling globally.
Well, and you mentioned India and Southeast Asia, obviously. So what you're planning to do is build fairly tight supply chains within each of the markets that you're going to address.
That's correct. I mean, and that's how we think we can actually optimize for cost if we do so, because the silent killer in any manufacturing business is logistics. Mm-hmm. You can look at your price and say, wow, I had such a great price. And you go look at your shipping bill and you go, oh, wait. These two things don't really match.
And the environmental benefits of a shorter supply chain are legion. So there's a lot to say for that approach to the business. Now,
we look at the supply chain holistically for sure. Yeah.
So if I'm a community thinking, boy, I'd like to have this industry come here, build a gigafactory is essentially the way that I'm hearing you describe this. What should I be doing to prepare my community? What investments, specifically in education, in order to have the workforce that would attract you?
Absolutely. And that is probably the major challenge. We can solve for a lot of the infrastructure challenges given enough time. Education is one that I feel that we have neglected for sure. My background, I went to a technical school for high school. And prior to going to UC San Diego, and the kinds of things that we learned from the ages of 15 to 18 were material science, electronics engineering type work, working in manufacturing. So the first time you showed up to an employer, it wasn't the first time you saw a CNC machine. It wasn't the first time that you saw automated handling. And so what I would love to see community colleges do, technical schools do, is develop robotics programs. Because even though you bring automation into a factory, somebody needs to fix that automation. And those are higher paying jobs than, let's say, material handling is. We need people that understand this, honestly, the fundamentals of just, hey, I need to show up on time, clock in, work my shift, contribute to the company, and continue on. And so we do, for example, we do hire a lot of veterans. We're very veteran friendly, as you can imagine. I'm one of them. And so, we do tap into that workforce because we have people that have technical skills coming out of the armed forces. They have the discipline to show up on time and to do the work that they need to do. But on top of that is also the fact that we need people, again, with that mechatronics understanding, great mechanical skills, people that have great electrical skills, electronic skills, controls skills. We promote people independent of whether or not they have a degree. We have a manager right now that didn't get a 4-year degree, and we don't care because he's self-educated, he's an autodidact, and taught himself the kinds of skills that we need to be effective and how we need to grow. So, but that's really important that I think that next that level of education is built out. And if a community can come to us and say, look, we have a curriculum that we're willing to customize to support you. These are the kinds of things that we want to teach. We'll bring people into the classroom as well to help complement the curriculum, give people opportunities for internships. And we're establishing that right now with community colleges in our area, where you have an opportunity to come in and be an intern at Caelux and learn what it's like to be in a high-tech manufacturing environment. So that is probably the single biggest challenge for us, is to ensure that we have that educated workforce.
So it sounds like we need a new education bill that's really designed to rethink, first, learning how to learn and how to solve practical problems, which is really what we talk about when we talk about a trade.
You're absolutely correct. And I had the same conversation with Representative Chu when she visited us about a month ago. And it also impacts, I would say, the construction trades as well. We've seen, I think, over my career, I've seen a decline of skill in the construction trades. And we need those people. We need the people that understand concrete, plumbing, electrical. That's how we either take a brownfield site, which we prefer, and then retrofit it to our requirements, or even building a greenfield site. And so we need great construction people, as well as we need great people to go and operate these factories and ramp them.
So let's imagine that we successfully make these investments and we produce this workforce and the setting in which this industry can take root and really flourish. What will the green economy look like in 2035? Will we be able to overproduce to the degree that energy is just ubiquitous and inexpensive, and that we are not concerned about the nighttime and the storage of solar power? What will life be like if perovskites have achieved the goals you have for them?
Well, I think I want to be quite humble about our contribution. I think just because I think when you look at the energy mix, it's quite complicated and not one size fits all.
Sure.
And I think we're an important slice of this. We are the future, I think, of PV is perovskites. We refer to it as PV 3.0. And I think that's an important contribution. We still need to have investments in storage technology that makes sense. Sure. I still believe in the proliferation of wind technology where it continues to make sense, offshore wind being key amongst that. Hydrogen in terms of long-range transportation and other industrial uses, I think, is going to be incredibly important. Carbon capture to clean our air. There are tremendous companies out there doing really good work. And I would be a little bit controversial here, and it probably reflects a bit of my background, starting off as a nuclear engineer, is, I do think there's room for small modular reactors today. Because when we think about EV infrastructure, that's a lot of power. And our grid today is not ready to support it.
We've had a lot of guests on talking about the need to reinvent our grid.
Absolutely,
as a distributed, more internet-like thing than it is.
I've been working in that space for probably 10 years or so, and been tangentially involved. And I've seen some great technologies, unfortunately, fail to gain traction because there hasn't been. I wouldn't say there's not a will to innovate. I think there's bureaucratic hurdles that prevent innovation and forestall innovation. There's everything from superconducting transmission lines that would reduce losses tremendously to voltage monitoring, control, and optimization systems that are designed for this solar-based approach to electricity infrastructure that, because of just challenges and the way we've kind of set up our regulatory system, makes it very difficult for innovation. And we don't incentivize utilities, and particularly investor-owned utilities, to innovate. And we have to have, I think, an open dialogue about how do we change that cycle. And everybody needs to come into that with a dimension of honesty and self-reflection to say, okay, how can we transform? We have amongst all the OECD countries, we have the poorest performing electric grid amongst all of them. And where you are in the Pacific Northwest, you'd think you would just have buckets of power, but I'm sure you deal with outages as frequently, very regularly. And considering all the hydro up there should be no reason why. But this is an issue.
Well, I think you also are gesturing again at what you said earlier, which is the biggest thing we can do to change the direction of the country and the world is to vote. But the voting requires the dialogue that you're describing. Do you think that we have and I hate to put it this way, the political environment to solve the problems that you're raising? And let me put the other question a little differently. What's the probability that we achieve the kind of energy independence that we were talking about by 2035, say?
Oh, wow. I don't know if I'd ever try to guess that, because oftentimes I'm surprised. I was very surprised when
Place a fun bet. Place a fun bet.
Fun bet. I think people are becoming more aware, and I think I'm more optimistic than I have been before. And I think so long as that parties on both sides see that there's benefits to their communities, then I think they're going to recognize, look, let's go and continue down this path. And this is why you see a lot of these projects, these manufacturing intensive projects, are being built in traditionally red communities. And I think I applaud it. In fact, we'll do the same. We will do the same, because I think it's important to extend the benefits of this renewable energy economy to everyone in the country. And it doesn't matter at the end of the day. And we have this conversation all the time here. It doesn't matter if you believe that climate change is anthropogenic or not, but when your paycheck is coming from that solar module company, then you're gonna vote in your own interests. And that's a good thing. It's a good thing for everybody. They've got jobs, and it satisfies both ends of the spectrum, I think.
Well, we see that as well. And I think you're really hitting on the important thing, which is we talk about the environmental benefits of this, but the immediate economic benefits need to be aligned with those environmental goals.
Yeah, exactly.
And, Scott, this has been a really encouraging conversation and really interesting. I want to thank you for spending time with us today.
Oh, well, thank you, Mitch. And I really appreciate the opportunity to speak with you.
We've been speaking with Scott Graybeal, CEO of Caelux, which, as you heard, is a developer of perovskite-based solar panel technology. You can follow the company at caelux.com. Caelux is spelled C-A-E-L-U-X, caelux.com. The $370 billion Inflation Reduction Act has reportedly been followed by between $213 and $511 billion in private investment, with hundreds of new solar, battery, and other cleantech facilities being launched over the past year. It's a remarkable time to be in green technology because, as Scott said, the U.S. has embraced an industrial vision and invested to make it happen for the first time since the Eisenhower administration. If you really want to fight government spending all the time, take a look at the highway you drive to work on and think about where it came from before you make that decision. Perovskites represent an opportunity to break the global green tech supply chain down into regionally oriented hubs that, while they may depend on some global inputs, rely primarily on locally manufactured materials and distribution systems. Silicon and cadmium telluride panels will certainly continue to play a huge role, with more production capacity coming online to augment an increasingly diverse and resilient solar supply chain. But we need electricity generation, storage, and distribution technologies to come online, and we need them fast. The challenge we face as a nation, therefore, lies in education. We need to train a workforce that can build and manage this new infrastructure, and we need to make the transition without abandoning the workers and companies that got us here, which is where much of the political resistance has come from. New jobs, new factories, and local tax revenue that can support increased investment in education has repeatedly overcome resistance to green technology. But a national educational strategy could deliver the same invigorating boost to the decarbonization transition that the IRA has over the past year. Caelux and perovskite technology will be interesting to follow, kind of bellwether of our success in the project of funding a new industry and training workers to deliver world-leading technology products. And we'll keep you up to date on what's going on with them and across the industry. Help you take a few minutes to share this podcast or any of the more than 420 interviews we've done with your friends, your family, the coworkers, the people you meet on the street, folks. Let's get the word out there. Take a moment to write a review on your favorite podcast platform to help your neighbors find us. And tell them you can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the other fine purveyors of podcast goodness that they prefer. Thanks for your support. I'm Mitch Ratcliffe. This is Earth911, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.